Hello everyone, this is Chinmay from Make Auto Clinic. Welcome back to my channel. Today we are going to discuss about one of the point and one of the spare which is basically which you should replace it rather than repair it. Reason, you should not take it, you should not consider that it's a normal repair or something. But if it is not available, then you don't have choice. So you must know what kind of a treatment you should give to that spare, because it may become life and death situation. Of course, I have taken the consent about it. My client wants to get it repaired. He doesn't want to spend money, number one. Number two, the spare is so much costly right now, so he doesn't want to spend. But he wants to get it done under repair technique. Correct? The cost of material is very high. Sometimes what happens that if the stock is not available with the company or with the dealer, then you don't have any choice. But if you do have, and if they have, then of course, as I mentioned, that if there is any financial problem or something, then we don't have any choice. We have to go according to the client. So I have already intimated him, and he wants to go for the repair. He doesn't want to replace the part. So right now I do have one 535 GT Continental, which is an old model, which is already out of production, which is not in production. This has got a floating disc in the front. The disc is too much costly, because it's an imported material. Some of the material is very imported in this vehicle, so replacement is very much hard because of the financially, and the cost of material is very high. So that is the reason he said that we will repair it. That's fine. But then if we are repairing, then it has to be perfect. It should not be like kind of a roadside technique or something which it will show you just like lipstick. Don't do that. It may create a lot of issues. So I'm going to show you how to repair or how to replace things to get it done perfectly rideable, under rideable condition. Correct? So let's jump on the video and check out all the details.
So this is GT535 older one. So the problem is to ask someone to hold the steering and
Yes, full tight.
And then you have to move the motorcycle. Have the actual data, stock data as well, but I will have to consider the cone set is not problematic. Generally, we tend to feel that the cone set is gone, but the cone set is not gone. This is not a cone set problem, this is the front disc problem, since it's a floating disc. Now what we are going to do, we are going to cut off all the rivets. These rivets are made up of special steel. Remember, this is not MS or aluminum. So you have to cut, you will have to cut, because these are pressed under machine. So you cannot remove just like that by using any plier or something, because the flaring of the rivet is already done. process. One thing what I found is that GT535 has got an imported disc. I'm not sure from which bike they have used. If it is made only for, if the product is dedicated to only Royal Enfield, then I'm not sure whether the rivets are available or not. So since it's an Indian product, I will have to make or manufacture those rivets, but only after designing. So I have cut down all the rivets. I got one rivet intact because all 5 I removed, and the one I could remove it without cutting it off. You can see the design, the flaring, the lock flaring and all. Now flower washer also they have used. It's a basically retainer. This is the center part of the floating rotor. Remember, this is aluminum and the main disc is from steel. It's a special steel. So these are 2 parts of the rotor, and the third part we have to make. So now we have to find out the center and everything, in short we will have to use a lot of mathematics. Remember, some people get into automobile business just because they are not educated, but it is not like that. Every trade requires education, knowledge, basic knowledge of other trades as well, so you can work on the material. I hope you guys can see. Now we have to find out the center, actually the circle of the rivet, right? But although we have rivets in our hand, so we can check the basic diameter of the rivet, and then we can compare with the existing one. Make sure your caliper is well calibrated. If it is not, then get it done from the person who does the calibration of these precision tools. I'm not sure whether you can see. This is somewhere near to 14. I cannot show you the I can show you how I have done the calculations, but I cannot tell you the number. Reason is that every disc is going to have different diameter because of the friction and wear and tear, correct? So giving you the exact number, like for example, if the existing diameter of the rivet is 14 and if I am putting some 14.5, you cannot use 14.5. I'll show you that in the, of course those things are coming up now in the same video. So first of all, we are going to draw the shape of the existing stock rivet. You can change the rivet design little bit, but I would prefer to keep it as it is. So this is kind of a chamfered or the conical rivet face from outside. It has got back and front face. Front in the sense which is towards the caliper, and the back means opposite to the fork, you can say. So that shape is very much important. If you miss the shape, then you can hit the caliper, because it has got very little tiny space in between the caliper foundation and the disc. So you have to make sure your drawing is proper, because the machine is going to do the job according to your drawing. Remember, he is not working on any kind of a calculation apart from the given calculation which is in the drawing. So you should know how to draw. You should understand what you have to draw, because those machinists are they are into industry, correct? So their machining work is absolutely depending on proper drawing. If you miss the drawing, if you give them wrong drawing, then they are going to do the turning according to your drawing, and then if it doesn't fit, if it fails, then your job will get destroyed. You will have to throw out the job. You can't recover the job. Of course, you can't put the job as it is, otherwise you will have problems. So better to work on the drawing properly, and calculations you have to do. These are very tiny, these are very important points while working on the precision jobs. As you can see, the shape of the rivet has got a kind of an umbrella or something, or a hut. Now we have to work again. I have worked multiple times on the same rivet to understand the diameter, because what I found, the main diameter which in the area which goes into the, or in between the say rotor, that diameter is little bit differing to each other. different than each other because of the wear and tear. So when I did the drawing, I tried to understand the rivet shape first, and then the calculation. Remember, your point 1 or point 5 is also 0.05. I'm sorry, or the tolerance is very tiny. This is already done job. This is not what you're manufacturing newly. If it was, then the design could have been better. But this is a reverse engineering. This is what we call reverse engineering of the job. So it is a very difficult job to do or draw to do. Reason is that each part is going to have different dimension. Reverse engineering is always tough because you don't know what are the tolerances they have kept and what was the stock part, because this is a worn out job what you're working on, correct? So you cannot find out exactly unless you are the you are the only designer of this job. Then only possibility is there that you can rework on the job. Otherwise, no, not at all. So you will have to have proper precision tools to calculate each and every point, because here the problem is that if I for example, if I'm making this diameter, 13.9 is the diameter of the rivet, and what if we require 13.95, then how you are going to calculate this? So this is the basic problem. This is a done job in which you are reworking. So you should know how to use vernier caliper or the micrometer, and you should know how to calculate, you should know how to draw, you should know the metallurgy as well, since you have to manufacture the product. So you just cannot use any random product, metal to do to manufacture these rivets, otherwise it will impact on the performance. It will destroy the disc while breaking and it will cause lot of problems. So you should learn all those things. Remember, I always say that automobile is not like that you are not going to school or college, so you get into that line. It's not like that. You have to learn everything. Without that you can't go ahead. Also here the main thing is that logic, how they have worked on, how they have manufactured the product, what is the design, which kind of a machine you should use to manufacture this product. You have to understand, because sometimes stainless steel cannot be turned on the lathe if the lathe is not proper. It has to be done on CNC. So this is the drawing. Do not copy the numbers, it won't work with you. Remember, you will have to make your own calculation. Design, yes, definitely you can see the design is not a problem, but numbers, it won't work. This design is almost 60% is correct, but 40% is wrong. Reason, I'll show you why it is wrong. You cannot help it because of the worn out spare on which you are working on. So now I am going to design new one by keeping this same shape, and I am going to put new calculations in that. Few of the calculations will be the same. Only main calculation is the diameter of the rivet, and of course locking system, because they have used different locking system. They have pressed the rivet under the machine and they have done the flaring lock. So flaring lock we are not going for. We are going to put circlips, external circlips. So little bit change in that, because the material, the source of material is easy for me, and making the flaring is not possible, because then again I'll have to change the tool room, which is not possible, which is very costly. This job itself is costly, of course lesser than the cost of rotor, because you don't have any choice. If the rotor is costing say 9 or 10k, it depends on situation condition. So I'm not sure whether we should buy or we should put this rivets as well. In foreign bikes, you will get some of the companies provide rivets for the disc. Of course, these rivets are made for the special disc, special rotor or special motorcycle. Unfortunately, we don't have, or I couldn't find, I should say, or maybe it is available and I couldn't find. So there is a possibility. Now, that's a very difficult task to find out, because we don't know the keyword, and some people doesn't even know about it. So it's very difficult. Of course, you can't even manufacture those rivets in bulk as an aftermarket rivets because the dimensions are going to get changed in every rotor, even though the rotor is from 535. Remember, that's not possible. So calculation is very much important. You have to work on very high tolerance product, and it is going to give you very tedious time. Remember, it's a very special job what you're working on, because you're working on the brake, which is an essential part, or the first essential part of the motorcycle. So drawing, and you have to understand first what is the shape and how to handle the caliper or the vernier caliper, not the brake caliper, but vernier caliper. You should understand clutching and declutching of the vernier, where to and I mean which at which point you have to calculate or check the diameter of the rivet. So as I mentioned, the main dimension is the diameter of the rivet. Shape, of course, you can change little bit, because since you are going to make only 6 rivets for this, so little bit changes acceptable. But make sure your design is perfect and you are using perfect or proper material to make the rivet, to avoid the failure of the brake. It takes time. Of course, you have to have some patience. Remember, if you don't know, then get it done from professional. If you don't know, then learn first, and then consult with some professional person, and then only manufacture it. If you don't know, do not get into this. From the beginning, I am telling you the same thing, because I have taken the consent from the client whether you want to go for or not, because of course it's a risky job. So this is the actual shape what I am going to use, the chamfer at the bottom, because that is the outside or the front side of the rivet, and the groove and the length of the locking mechanism. That's very much important, because if you have wrong design, the lock may pop out of the rivet, since you are going to use circlip. So now I am going to make another drawing to give it to my machinist. Unfortunately I cannot work on CNC or normal lathe. I don't know how to use it, so I'm going to give it to my machinist, a professional guy who will do it for me. Remember, some of the points are very much important. So while cutting or before cutting, first learn why they have done this, why they have done that, and what is the reason, what can cause. So randomly you just cannot make anything in manufacturing, and especially if it is reverse engineering, then remember, you have very little space to move around, because dependent products are already made or the spares are already made. So you have to integrate your new product in that existing product without damaging or without altering the old stock spare. That's how, and that's where you have to show your skill. Which is the center line and which is the dotted line, that's very much important. That shows or tells the machinist what he has to do. This is the industrial language or the mechanical language. Remember that you should know. Every trade has got their own language. So if you make things wrong, then very difficult. This is my first job, and I thought like sharing with you, because I have seen many times, but I haven't done this. I just got the opportunity to work on, so I'm just recording these things for you, so you guys can understand or can have the knowledge of engineering drawing and mechanical things, because floating discs are not there I mean, at least here in India, there are hardly some motorcycles which are having floating disc. Number one. Number two, hardly some people get to know the problem. Number three, hardly some people make those rivets, because some people change it. Of course, if the disc is worn out, like if the thickness is gone, if the thickness of the disc is gone or the rotor thickness is gone, if it is not in permissible limit, then of course you will have to replace the rotor under any circumstances rather than repairing it, because we cannot repair the surface or the thickness of the rotor. Remember, replacement is always better. But if the rotor thickness is perfect and the rivets are gone, then you may think about it, if you are confident enough to manufacture these things. I have a lot of sources over here, because being a Punekar, I am in Pune. So industry is very much near to me, and I know a lot of industry people who works on many things. So I have a lot of sources over here. That way it is not difficult for me. Now you can see thickness is mentioned. This thickness is different and the rotor thickness is different. So this is what I have calculated is the center portion thickness. I am going to tally that, because as I said that it's a worn out spare, so it is not necessary what is printed on the rotor or the center part of the rotor is the same, or you are going to get the same thickness as per the printing or the printed thing. The very worn out disc, I mean the surface is safe. So fortunately this rotor surface is perfect, I mean the thickness is in permissible limit. So that's the reason that we took the decision that we should change or not. Thickness, dimensions, metal, treatment, process, drawing, knowledge, understanding, everything matters. So all the rivets has to be same. Of course you cannot change a design for each rivet, and you can change the design or the dimensions only for different rotor, not for this rotor. Vernier has got 3 points where you can use, I mean vernier can be used 3 ways: ID, OD and height. Since I don't have height gauge, so I am just using vernier bottom side only. Although this recording is very old, I worked on this long time back, just because of the time I couldn't upload this video, but I kept it aside deliberately so you guys can learn those things. Now again the diameter is different, so I'm like a little confused what to do. Although design, I have done I have made the design, but unable to understand the height, or rather than that diameter of the rivet, because all the holes are eccentric. These are not exactly in circle because of the play. Remember, floating disc has got permissible limit, I mean the play in the rivets, but not too much. If it is too much, then what you have seen in the beginning, it is just little play, because play, sorry, because the rivets are eccentric. They are not exactly in circle. Because of the play. Remember, floating disc has got permissible limit, I mean the play in the rivets, but not too much. If it is too much, then what you have seen in the beginning, it is just little play, because a little play is important, because that is deliberately given to absorb the vibration which comes from the braking, right? So of course there will be some play, but not too much. Now here I can't do anything. Reason is that I don't have stock number of play or the tolerance. Even if I do have, I cannot control that, since all the holes are different. So that is like a little difficult thing to control. But I can use my skills as much as possible to control all those things. So it is better to work on this properly rather than neglecting. I have checked all the diameters of the existing rivets, and I found that none of them are matching to each other. Reason because of the friction which caused the damage or the vibration. Of course, that is normal, that is expected, but tedious. So what I am going to use is that I am going to use no-go gauge. Now what is that exactly? So since I have one opportunity, I can say, as a source, so I am going to cut the MDF, these small washers or go-no-go gauges, and as per the diameter, the drawing diameter, as a sample or the replica of the, or instead of the rivet, because manufacturing the rivet and testing is not possible, that is more costly. Best is to use some kind of material which can be used as a go-no-go, which will be less costly before manufacturing the actual product. So what I have done is that I have used this MDF 2.1, you can use 3.3 as well, and I made some dimples out of it, and going to put it instead of rivets. I'm not sure whether the diameter is perfect or not, because on the paper it shows me and even on the caliper it shows me, but because of the variation there is a possibility that I may not be able to use these dimples or may have some problem with it, so I may have to cut it again. So I will have to change the tolerance, I will have to keep on changing tolerance. So that is the reason I have made it out of MDF, less costly and immediate. So now instead of those rivets, you have to keep the, or you have to put the, or you have to insert these dimples in the hole, in the rivet hole, so the disc or the foundation or the plate should get stuck to each other properly without any movement. This is how you have to calculate. You can use some other skills or ideas as well. There is no particular demand of ideas. You can use anything, any ideas to make it proper. What I found, this is easy thing for me, so I made it. I'm still getting play, so vertical play and horizontal play is important, or the jump out, just like your wheel rims, in the spoke wheels you get jump out and side out. So you have to find out all the problems, and then you have to make sure that the gauge will give you proper dimension. So you'll have to keep on making the gauge. Go no go, in the sense, the one which goes easily, that is called go. The one which goes very hard or doesn't go, then it is called no go. So it should go properly. So of course go means perfect, no go means imperfect. So this is different, this has got different diameter. As I said that I made multiple dimples as per the dimensions, as per the tolerances, and then tried everything here only in my workshop, and then gave it to my machinist for making the proper rivet. it should not move. It should not move vertically or horizontally. Horizontally you can't check, but vertically yes. This is actually vertical. If I fix the disc on the vehicle, then this is vertical side. So currently if I am using 13.2 or whatever 13.9, so I must cut again and make it either 13.95 or possibly 14 mm. This 0.05 or 1 mm makes huge difference. Huge means huge difference. As I said that this is reverse engineering, we don't have the stock data, so we have to make it so proper before cutting the main rivet, because machinist is not going to change the dimension or the setting of the tool all the time as per your demand, since these rivets are only 6, not in bulk, and not having same dimension. So even if you say that send me the rivet, I will cut it and I will fix it, that's not possible. You will have to send the disc to me to make it proper, because if I send you the rivet then it won't fit, then you will have to send the disc to me again, and you will be spending money on the existing rivet which are made for you, because this is made to order. Remember, I cannot keep it in bulk with me, that's not possible. So I'll have to keep on working on each disc or each rotor different way. The process is same, dimensions are different. At least main, which is like I can say that 10 or 20% dimensions are different, but these dimensions are important. Other part is just a shape, so I cannot follow the same dimension to all the rotor. The same process will be used once you send the rotor to me. I am not sure what is the cost, but cost of the disc, but I guess it is not less than 9k. Of course, INR. So this process costed us not less than and not more than, say, in between somewhere around 2 to 3,000 rupees. And yes, I can get it done in the week or something. If the disc is available, then better to go for disc. If it is warped or if there is a major damage, then do not try to work like this. I would prefer to replace the disc. There is still play, that means these dimples are also wrong, so this comes in no go. So I still have to go for another one. I'll have to cut another one. So I have done that already. I have bunch of dimples around with me to make sure the product is now, the rivet diameter is perfect before giving it to my machinist. These are now very little diameter change in diameter, very little, but it took my almost whole day. You can see a lot of dimples I have now with me. In set of 6 they are different. If you press the MDF will get adjust itself. So you cannot sure about the MDF as well, because MDF can get worn out immediately because it's a soft wood. So while pressing the dimples in the rivet hose, the MDF gets adjusted and changes its diameter. So the problem is what, you cannot use acrylic as well, because acrylic is too much costly. Also it is just temporary, so I thought of using MDF only, and it will not even damage the surface or the metal as well. and easy to cut, and it was easy for me as well to source out because I have everything in house. So in this case also, when I check these MDF dimples or the washers or the shims, after removing it, I found the diameter is little different than each other. So I had to work on again on the perfect shim or the dimple. Now this is perfect. This is quite perfect. So the play has to be there. This is quite perfect. The play has to be there. The tolerance has to be there, but not too much, which can make lot of sound. Not too much. Just very little. Now the job is done, so I have marked that which diameter is perfect, or you can still calculate again, and then according to that I made some changes in the drawing. So that is how you have to work on that, so that your machinist can also do the job according to your drawing. The drawing, as I said, 80% was perfect, 20% was imperfect. I had to make some changes again later on as well. See, reverse engineering is always tough because you don't have any proper dimension in your hand, and stock design you don't know, so you have to depend on your own skills and understanding and knowledge. But that's the work, that is where you have to work on. So now we are almost finalizing the drawing, which will give you proper product. Also remember, wherever there is a fine edge, make sure it has got a chamfer, that is called insertion chamfer, so that helps you to lock the rivet properly on the desk, like using a proper circlip and washer. If the insertion chamfer is not there, if the burr is there, if the edge is fine, then it won't go in the rivet hole properly. This is the drawing. This is the almost final drawing. I'm saying this is not 100% perfect. This is almost perfect drawing. The diameter may get changed. So that's the reason I cannot show you the numbers. If I show you the number and if you follow the number, then you may make something wrong. So best is to make your own rivet, but the process is same. Did some cutting or use some flywheel, cutting flywheel with the help of grinding machine to cut the rivets. If you get it in your hand properly, so you can redesign it properly. Of course you need to have some references. Without reference you cannot make your own, unless and until you have proper at least tools and everything, right? So the reference point is important, and from that you can start your design. The beginning is that only, and you have to make sure you are cutting it properly by keeping yourself safe, and by keeping the rivet as well in a safe condition, so you can retry the design without any problems. So I'm still designing, I'm still thinking what could be done, what is the best, why it is wrong, how it has to be, and all those things I have done. Do not calculate those numbers, or do not take these numbers. I have just done the calculation according to this rotor. Your rotor may give you different numbers or calculation. So dimples, of course you need lot of dimples. For that you can use something else as well if you have in your mind, so that you can design your rivet properly. And after this I'm going to give this design or the drawing to the machinist for machining purpose with the material. You can see this is what I found, 14.3 I guess, or 14.2. And then after machining we are having this rivet or these rivets, stainless steel 304, SS304. Everything is in SS304. not only rivet but lock, washer, shims, everything is in stainless steel. Now there are many surprises. Of course, I've been working around on this from long time. I mean, in the video you must have seen I was working with cutting, chopping, design, everything. Right now, lot of surprises in the sense. I'm not sure. Am I having perfect unit or not? That we are going to get it now. Now this is a peak time. Also make sure that I told you that before cutting you have to make sure that you have marked the plate, the center plate and the main rotor, its direction and its face. Once you are done, then you can start putting up the rivets. Clean the disc, both the rotors or both the plates, so the dust will not cause any problem while fitting, because as I said, the tolerance is very small. So because of that, there is a possibility that the dust may cause the issue while fitting, because you may need single shim or double shim only because of the dust thickness, you know. So best is to clean the disc properly before fitment, because while working this I found that still it was not proper, and without making it proper I was unable to put it on the vehicle and it was risky. So you can see, you can check out in the coming up time. That's the reason this video almost went for 1 hour, because problems, see, without problems you cannot go ahead. You cannot make anything 100% in one shot or in one go, right? You have to work on those things. You have to find out a lot of problems to make it perfect. So once you start removing the problems, then the product will become perfect. Then it starts becoming perfect. All the errors should go, and then only you can use the spare for refitting purpose. So the rivets I made. Now placement time. First of all, placement time. Do not think about the alignment, because once you place the rivet, then you will automatically get to know that there is some problem, because whether it is central line or horizontally, I mean horizontal and vertical, like jump out and side out, that is the most important thing. So once you remove the jump out, then you have to think about side out. So jump out means what? The plate should not wobble. Now these are the shims. After this I found the job or whatever the thing I have done is almost 99%, remember 99% correct, but I am sure 1% is not proper, because I cannot achieve that. It is very much impossible since it's a used rotor. So placement of rivets done, then the washers and then shims. And now locking time. Make sure your metal is proper. I mean, if you are not using any other metal like brass or copper or aluminium or MS, do not use those things. Stainless steel, apart from stainless steel you can use steel, but then you will have to go for hardening, then coating, and anti-corrosive coat you need for that, because it may get corroded because of the water, because this is at the very bottom side, almost near to the bottom, so water is going to get corrode the unit. So best is that use stainless steel. Anyone can use, I mean anyone can work on EN material or the steel, but stainless steel is little hard. So your machinist has to be perfect, the turner has to be perfect to do the job. In this now part, you will see I have removed multiple times those locks and have checked multiple times that if there is any side out, because if the side out is there, then wobble will be there. If the jump out is there, then the caliper will get damaged. In fact, caliper will get damaged in both the conditions, but less in side out but more in jump out. So again, something I found that some rivets are still loose. You can make out the rivets are coming, they're moving around inside the hole. So step by step I'm going to make it stable. Also make sure you are stabilizing those rivets from only one side, not from both sides. If you try to do that, then your rim or your disc or the rotor will be having uneven surface. So it will have feathering effect on the brake lever. About the feathering effect, I have already made one video and I already posted that. Feathering happens because of the warpage. So the same symptom will be shown if the rim or the plate is side out. It will show you feathering effect. Fortunately, both the plates are not warped, not bent. So that is the reason we checked all the parameters before working on the disc. Because without that, manufacturing is total loss. Without understanding the disc condition, if you make the rivets, then it's a total loss. Because as you can see, although the video is almost 1 hour, but it is not like that. I spent my almost whole day on designing only, and then manufacturing. It took another 3 to 4 days to manufacture the rivet. So your things should not get waste, so it's better to check it. I'm still fighting around with each rivet to find out the movement. Make sure the disc, the center portion and the rotor or outer plate is not having any kind of a play apart from rotary play. Slight is fine, but not horizontal and vertical. Rotary play is fine because that you need to absorb the vibrations. As I said that this is not 100% perfect, this is almost 99% perfect, at least from my viewpoint. So two are still having problem. This is the back side of the rotor because this goes towards spoke. These two rivets are still moving around, so I will replace, or I may add some more shims to stabilize it. Because this precision cannot be controlled or even on the lathe unless until it is a CNC, because lathe is end of the day it's manual unit, so you can't control a lot. After adding some shims, again we have to check. You have to keep on checking around. You just cannot say okay, perfect. So make sure the lock is properly locked inside the groove or seated inside the groove. Otherwise it may pop out while riding the bike, and also it may get expand because of the heat. So make sure whatever you have designed properly to avoid the further damage while riding the bike, because you never know how a rider is going to ride. It is a high speed or low speed, right? So once you are done, then again you have to check if there is any movement or something. Now this is the last rivet. I mean, it got out of the hole, that means it is quite loose. Now this is locked, all the rivets locked properly. Recheck every time you feel that you are done. I still feel there is one rivet which was not causing any problem, started causing problems. So why? Because I may have misunderstood the checking. So check 1000 times before placing it on the hub, because it's a brake, it's a matter of brake, life and death situation may happen. So be careful. If you are not confident, then I would suggest don't go for this. Well, I have not taken the responsibility since customer wants to get it done, so I have done this. So this is almost perfect, no movement. Let's see if I can. I just want to make sure that the rivet is perfect. May try to add one more shim if it is possible. Shims are very thin, they are very thin. See, it's like 0.02 or 0.03 mm or something like that. They are very thin. Fortunately, those shims I use it from cams only, because the hole was almost same. So procurement of shims was not that headache for me. But also these shims are available in the market for multiple things or multiple work. At all, of course, in industrial area only you will find such things. You cannot get it from any auto store, even though you are using it in auto. There is a misconception that if you are working on any automobile or vehicle, then you must get the spare only from automobile store. It is not like that. You get the things available even in industry as well, because industry is the only one unit which manufactures the automobile. Of course, it is made as per the order, so non-standard things are there in automobile, but some things are standard which can be used in directly from the industry. Now this is perfect, no movement at all the rivets are tight. Now there is no problem. Now the last job is very much important. Remember, make sure lock. This is the second face or the front face of the disc. Last point is very much important, that make sure the lock is inside the groove. I mentioned this sometime back, but I still would like to, because locks are the crucial and the last point in this unit, because if it is in unlocked condition, then the rivet may fall down. So make sure things are properly locked. So you just have to use one small rod and tap it on the lock, which will help to sit the lock inside the groove properly. Otherwise, the problem is that if the lock pops out of the rivet, then the rivet will come out and it may stuck inside the caliper. So that is then worst. So this is how we have worked on the front rotor, and then you have to fix up on the bike and you have to recheck again that the thing is working properly without any problem. Rivets face, you can see one side is common, same, there is no shimming from one side. The shimming is only from inside the rotor, which is towards the spokes. So this is the last job. And ready to go.
So guys, you just saw all the details. I have worked on the floating disc and I repaired the rivets. These rivets are not available in Indian market. Of course, in out of India, those rivets may be available, but I don't know what will be the cost of that. Number two, there is a possibility they are having rivets for this particular disc because this is an imported Brembo disc, right? So quite possible that I may find out, but I couldn't. So I had no choice at all. So I manufactured the rivets and fitted it properly after designing it properly and by using proper material. Metal is important. Metallurgy has to be perfect. You should know what kind of a metal you have to use for that. That is the main point and key point of that repair. Otherwise, everything will go on toss and the rider may have a lot of issues. So guys, whenever you're working on such spares, of course you have to take care of that. Without understanding the metallurgy, the design part, you should not manufacture anything because it looks very simple, but it is very difficult part. Understand that point. And I hope you understood the repair work, and I hope you like the video. So subscribe my channel, like the channel, and share my videos as much as possible. If you would like to donate anything, then I'm posting my QR code after the video. You can donate if you want. And thanks for watching all the time, and I'm so grateful for that. Have a great day and keep watching.